So there's our square. And let's say we built this square so that it's 1 unit on each side. And that's actually not hard to construct. I can use a protractor, or I can use a compass and the straight edge to make a line, make a right angle to it, mark off 1 unit, and 1 unit, so forth all the way around. So then it begs the question, how long is that diagonal? I mean, I can measure that. I can put that in my straight edge, say, okay, there's the diagonal now. How long is that? Well, from the Pythagorean theorem that we worked on last week, let's plug in what we know and what we don't know. C in this case would be what we're trying to find, the hypotenuse. So we'll leave that as c squared. And then these 2 legs are each 1. So this now becomes 1 plus 1, this square is c squared. Or 2 is c squared. Or c is equal to the square root of 2. And what that does is it now introduces an irrational number into a very straightforward, simple situation. A square, the diagonal, if even if the square sides are normal numbers, the diagonal is automatically going to be something related to the square root of 2. And I can extrapolate this idea out even further. Let's say I've got a right triangle like that, and these 2 side angles are the same. That's 90 degrees. How big are those angles if they're the same? So 65 plus 65 plus 45. Yeah, 45 plus 45 gives me 90. Plus 90 gives me 180. Let's say this side is x. It's some number. Don't know. Call it that. And so this number is x. Same setup. But I want to know what the hypotenuse is. Let's see. That gives me, let's see, x squared. Plus x squared is equal to c squared. 2x squared is c squared. So I take the square root of that. And when I simplify that, I get x times the square root of 2. And so there's that irrational root 2 again. And when I talk about the historical perspective on all of this, I've talked about this idea of this square root, this irrational number being a bit of a problem because it's not something I can build easily in terms of parts of this line. It's not a half of it, it's not a quarter of it, it's not any meaningful fraction of it. Mathematicians spend a lot of time trying to figure out how to get that diagonal down to a rational part of the 1 unit. And what's nice is even though they were never able to do that, we can still use this property to quickly pick out measurements on any isosceles right triangle. And that's the first special kind of right triangle we talk about. The isosceles right for 45, 45, 90. So that's actually the name of the section. It's one of the 2 special rights we're going to talk about.